Hi everyone, my name is Steve Tischer with American Consulting Professionals, and in this webinar I'm going to show you how you can use OpenBridge Modeler to do your preliminary geometry layout. I'm going to start off by covering pier and span layout, get into the framing plan and check minimum and maximum overhang distances, show you how to deal with changes to the roadway geometry, check vertical clearances, and take a quick peek at the geometry reports that are available to us. So we're going to take a look at a common scenario here where we're given a rough concept for a bridge layout from an RFP or a PD&E study, and we want to take that and modify it and try to optimize it as much as we can. Now the first thing I did was model the bridge the way it was originally in terms of spans and pier location. The original intention for this bridge was for it to be a 4-span steel I-girder bridge with spans 1 and 4 being about 220 feet and spans 2 and 3 being about 260 feet. But I think I can optimize the cost and shorten the spans 1 and 4 up enough to be able to use concrete girders. Because of this, one thing I did change from the original concept obviously is change those girder types on spans 1 and 4 to concrete girders so that I can make that optimization. And I did also leave all the original span lengths the way they were. So now that I have my model in here just the way it was for the concept plans and I'm ready to start seeing how I can optimize the bridge, what usually happens? You get a call from the roadway group saying that they're changing the alignment. It almost never seems to fail that this happens, and it used to be a pretty big deal, requiring a lot of changes on our end, but it really isn't too bad anymore. So what's the best way to deal with this? Well, one thing I like to do in these preliminary phases where roadway geometry can change at the drop of a hat is to add the date that I imported the roadway geometry to the name of the file. And we can see that here in the references. So this is the alignment when I first imported it, and this is the alignment here when roadway made a change to it. You can see I had the date added on the end of it so that I can clearly know when it was that I pulled that geometry from the roadway geopack file. Now I like creating a new alignment file to reference in that's separate from the original one because that will allow me to turn the old alignment reference off and turn the new one on to make sure that I'm selecting the correct alignment when I set the active alignment and I update it. Oftentimes the changes to the roadway geometry are very small and it can be difficult to see the difference between the two. By managing it through your references in separate files, you can't make a mistake by doing it like this. So I'll go ahead and turn the current one, or the old one, off, I should say, and then turn the new one on here. As we can see, it kind of shifted over about 10 or 15 feet or so. So again, just keep that new one on and turn the old one off. Now that I have the new one turned on, I'll go ahead and set the new one as the active alignment. And you'll see how the entire bridge model moves over to the new alignment automatically, holding all the original station values. Now one mistake you might make is by trying to click on this 3D alignment here, which that's not the one you need to click on when you're setting your active alignment. You actually need to click on the 2D alignment. So I'm going to go ahead and click on that one right here. And I'll zoom in a little bit so you can kind of see how the bridge moves over when I move this. So you just select it, let it run, and you'll see the bridge shift over. So we'll take a little bit of time here as it's doing a lot of math in the background, moving a lot of things over. And there you go. You just see it shifted all over to the new alignment. Again, holding those original stations, and everything is just the way it was. Now we may have to go in there and tweak certain things if it's a big shift like that one was right there. Like you can see some of my bearings might have gotten offset here when that got moved. Those ones look good there, but again, I think the headspan bearings here might have gotten either deleted or moved, so those are some things I can go in there and fix after the shift. And actually in this case, it looks like the shift is big enough that it might have just deleted one of the girders here, so I can easily go in here and click on that girder set, hit properties, and make sure that we get that one added back in there. And I'll just copy the properties from the previous one back over to that one. Hit OK. And there we go. That looks better. Now I got my girders back in there just fine. Bearings, beam seats are all good. And everything's the way it looks like it needs to be. So this is pretty significant. I mean, these kind of changes when a roadway alignment or profile changes drastically, these kind of changes used to take, a lot of time to update and see what we needed to do with the bridge geometry and everything. And to be able to have it just move it automatically to that new alignment and then make some minor modifications if something got deleted like that girder there is pretty big. I mean, that's a big time saver there. So now that I have my bridge moved over to the new alignment, the first thing I'm going to do is start checking beam lengths, min-max overhangs on my concrete spans. I want to be able to maximize these as much as I can in order to reduce costs and reduce the steel span lengths as well. So I'm going to go over to a wireframe view. It's a little easier to see what's going on over here. You also see some line work here, this pink and orange and red, and then the green and orange up here. These are some utilities that I have turned on. That way I can kind of see what I need to avoid with my foundations and when I'm adjusting my span lengths. And I'll also go ahead and turn on some of the roadway files so I can see how far up I can bring this end bent and shorten it and shorten the span. So you can see here I got the main ramp with some side slopes coming down, and based on how this looks here, I can tell already that I can move that end bend up a good amount and shorten that span to get this span short enough for concrete girders here. Originally the concept is about 220 feet. My max span length with the biggest girders I have available here in Florida is about 200 feet. So I need to move that up at least 20 feet in order to get into the concrete span range, which I think I could do just based on looking at this, but we can take a look at it right now. So I'll start off just by looking at the framing plan here and seeing what my girder lengths are with the current stationing and configuration. So yep, just kind of like the concept plan, it's looking at about 225 feet or so right now, which is too long. I'm just going to start playing around with the stationing of that end bent and seeing how far I can get it closer up to that ramp in order to shorten that span length. So it's a little busy in here, so if we can't quite see what that station is in there, then we can always open up our Explorer and modify things in there. Let's go down to the OpenBridge model, start expanding these till you find the unit you want to be in. I'm in unit 1 here, and let's look at those support lines. Oh, sorry, not the supports, but the actual support lines here. So the first one is at a 626.77 station here. I think I can get that moved up a good amount so that I can avoid the ramp here and get it short enough to get those concrete girders working. And in this particular one, just by clicking on it here, I can tell that this one was actually set with the parallel offset tool from this one here. So if I click on that, I'm going to see some dimensions here, and this is where I can actually modify that stationing there, but with that offset. So I'm going to go ahead and turn off some stuff to make it a little easier to see what I'm doing here. So I'll go ahead and turn off that roadway file just for now. And I'll even turn off the girder concrete, I think. And the haunch concrete, there we go. Now it's a little clearer there. So now all we're seeing here is the framing plan. So just like I did before, I'm going to click on that support line, and I'm going to go ahead and change this center value here. This is the offset from the Pier 2. So I think I can get that down a little bit here. So I'm just going to go ahead and click on that and put in a smaller value and see where that gets us. Alright, so that brought us up here. Let's turn on our roadway file now and see where that puts us in relation to the ramp. That looks good, and that's probably about as close as I can get that end bent before I start impacting that ramp there. So I just was able to shorten that a pretty good amount there, and let's take a look at that framing plan to see what my beam lengths are now. 134 feet. That's perfectly reasonable. More than enough. I can even get smaller than the biggest girder in there now, I think. So that's a good job right there. We just shortened that span up a good 70, 80 feet right there, and I can tell that it's not going to conflict with my roadway ramp anymore, and I know I'm going to get some reasonable beam lengths. So we think we can make that first span a concrete girder span and save a pretty good amount of money right there. Now I'm going to go ahead and tweak one of these girder spacings here. And now with this layout, the next thing I want to do is check those overhangs, right? Because we have minimum maximum overhangs that we usually have to adhere to depending on which state you're in. So I'm going to go ahead and turn off that roadway file again just so I can see a little bit better. And then let's take a look. This is a new feature here that they've implemented a couple builds ago that is extremely useful in this exercise we're doing here, where they actually will calculate and show you what your minimum and maximum overhangs are for your span. And now it checks at the ends, the center, all along on the left and right side to give you the minimum and maximum overhang distance on the left and right side here. So this is something that we usually have to do by hand in 2D, and it was kind of a monotonous task, copying offset and measuring over. And with this, it does it for us automatically. So in our case here, we have a minimum requirement of 2.5 feet, so we're good here, just by a 1/4 inch, and a maximum of 6 foot. Right now, it looks like we're around 5 foot max on the left and right side. So this is good, based on our overhangs and our girders. This is a good modification to that span 1 there that we can make. So I'm gonna go ahead and hit save to accept that. And I can turn that girder concrete back on and the haunch concrete back on so we can see our beams in there. Now, with relation to the utilities I have in here, this looks pretty good in here. I am going to make one little small adjustment to that pier though, just so that I can kind of dial it into where I want it. So I'm just going to click on that pier line and try to zoom in and see where that station's at. And go ahead and update that. All right, that looks good. I got that pier dialed in where I like that. This whole first span looks good. And let's go ahead and take a look at that span up here now. And we're gonna go through the same thing. Just look at the span lengths, overhangs, the pier locations, foundations, and see where I can get that pier at and how much shorter I can make this span. $220 foot offset to begin with. Try something like 170. And we got that span shortened up. And now let's turn on that other roadway file to see how that works with the ramp there. And that's fine here. And I do know that there was a bike path that kind of came around this area right here. So I don't have that file reference in now, but this is about as short as I can make that from that bike path there. So let's go ahead and take a look at that framing plan now that we got that span shortened up. Turn off the roto file to get a little bit cleaner. Let's go ahead and check those girder lengths. 170, well below the 200 that I was looking for, so that looks fine. And let's look at those min-max overhangs. Okay, so we got 2.5 or 2 foot 8, 2 foot 8. I'm above my minimums. I'm a little bit over my maximum, so that's fine. I'll just have to do a design or design variation for that, but still within the realm of reason. So that looks good. And there you go. So now I was able to quickly go through, see what those span lengths can get down to in order to make the concrete girders work there. And it looks like both of them are going to work just fine. And actually, one thing I forgot to look at was the utilities up in this area. After talking with the utility coordinator, I did find out that these were going to be relocated, at least this one here. So I can push this footer up closer to this buried fiber optic up here. So I'm going to take a look and see what I can do with this pier line here, and again maximize that concrete girder span, so it's going to be cheaper than steel, and shorten that steel span there. So these pier lines here were set with the multiple tool, so I can just hit the modify. But first I got to make sure I have that unit active. I know that was a unit 2, so I'm going to set that active and go ahead and hit modify. And the one I want to modify here is pier 4. Let's see what I can get that down to. Let's see if we can get that maybe like 30 foot or so shorter, possibly. Let's go for like a 135. And we'll just tweak this middle one here while we're at it. And those look good there. So let's give that a shot and see what that gets us. Alright, that looks pretty good. Now again, I know this screen utility is going to be removed. I'm not too close to this buried fiber optic here. I don't really want to get too much closer than that though, so I like where I put my pier head now. Now let's go back and take a look at those overhangs again and the beam lengths to make sure we're still within our preliminary design assumptions. Alright, so our chord lengths are still good. Those are still about 170 feet. Let's go ahead and check those min-max overhangs now. Still good. Looks alright. Hit save. And we're looking good. So now that I have my piers where I think I need them to be, my span arrangement the way I need it to be, I'm going to show you how to take a quick look at the underground utilities here and use that clash detection tool. So the clash detection tool can be found up under utilities, under clash detection here. So go and click on that. And there's lots of different ways you can set up the clash detection between levels, references, named groups, things like that. I'm going to go ahead and create a new job here. Utility check. And I'll make this a little bit bigger so we can see what's going on here. And then kind of zoom out so we can see the area that we're looking at. So I want to check the utility here, that buried fiber optic against the footing and the pile, and see how close they really are. So I'm going to do that with the levels in this case here. So for the first thing, set A and set B, these are the two things that they're going to be checking to see what the minimum or maximum distances are between them. So under set A, I'm going to go ahead and set that as my utility. So I'm going to take that buried fiber optic and set it over here. And you can see once I drag it into that set A, it's going to highlight that color. So it's red. So it's a good visual aid to see what it is that I'm setting for that first set. And the second one, I'm going to go ahead and use the pile concrete level and the footing concrete level. So let's go ahead and find those. Concrete pier footer, drag that over there. You can see highlighting there, and I'll also add my pile concrete level. There you go. So now we can see what it's going to be checking against, right? The red is the utility, the blue is going to be the footing and the pile. That looks good, and I want to see if it has any direct clashes at first. So if I hit process, it's going to find no clashes, right? So I'm going to go back and modify that rule and to see how close that really is. So if I think it's probably within 5 feet of there, then I'll go ahead and set that clearance for like 5 foot. This is a soft clearance, so this is just going to check for anywhere where it's less than that 5 feet space in between the utility and the footing or the pile. And here we go. So we did find one where it was. And this will give you the exact clearance here. And if for some reason you don't have the clearance column here, one way you can find it is by right-clicking, show columns, and making sure you have that clearance turned on there. Sometimes that's turned off by default, so you want to just turn that on there. So now I know I have an exact clearance of 2 feet and 4 inches between the utility here and that footing here. And I talked to the contractor, and that's been deemed acceptable. If you want to take a closer look at it, actually I'll cancel here. You can zoom in and rotate around and kind of see where that is located at. So that's looking probably right around here. That's where that 2 foot 4 1/8 inch clearance is. All right, now we showed you this clash detection tool for checking utilities against foundations. We'll take a look at the vertical clearance check you can do real quick. Now you could use this same tool, this same clash detection tool, to check your vertical clearances. That can get a little tricky because a lot of times when you have your terrain, I'll zoom out here and turn my terrain back on. Actually, let's turn those utilities off real quick. Let's get those out of the way. Terrain's turned on, so I gotta turn on the levels. And let's go ahead and turn those back on. So now the tricky thing about using that clash detection tool with the terrain is the fact that the terrain is much bigger than you really need it to be. You really only want to check the riding surface, the roadway surface, versus the girders to make sure you have your minimum vertical clearances and things like that. So one thing you could do, terrain's really easy to clip, so we could draw some shapes in here and clip out and only get the terrain of like the roadway surface, the existing roadway surface, and then run that clash detection. And then that's probably the best, most accurate way to do it, right? Because you're going to get an exact measurement, an exact check of everywhere in the model to make sure you have your vertical clearance. But another quick way that I like to do it actually is by just cutting cross sections and going in and checking that way. So to do that, go into the Civil tab, open cross section, and in this one I actually like to have 2 different views open. So I'm going to keep my view 1, my view 2, and go ahead and tile those. And the left one, I like to keep that in a plan view. And in this one, I'll actually turn on another one. I'll turn on like view 7, something I don't use very often. And turn this one back off and then tile those. So I'll go back to that Civil tab, hit open cross section view, select my alignment, and then the first thing I'm going to select is my left offset of the cross section. So I'll just go just outside the bridge limits. Same thing with the right offset, just outside the bridge limits is fine. And start station. All right, let's check where, roughly where I think that minimum vertical clearance might occur, based on the cross slope. It's probably somewhere around here maybe. And it's good enough right there. Select the interval, 1 foot interval, so that way we can jump in 1 foot intervals and kind of really check closely along that alignment for the vertical clearance. That looks good, and I'm going to select an open view. So I have that view 7 open already that I don't use too often. So I'm just going to click inside there, and then that'll open up my cross section view here. So now with this, you have the exact station you're at up here. You have your elevations on the side here, and you can always zoom in and just use the measure tool to see what your clearances are. You can, like I said, you can zoom in and get the exact elevation to the bottom of girder, and your proposed ground line, and just do the math and get your clearances that way. Or you can just kind of measure along here, lock in that vertical plane with that, and check to see what that clearance is. Plenty of feet here. This is a 2nd level bridge, right? We have other bridges going underneath this one here. It's a flyover, so we're going to have plenty of clearance to the existing roadway surface. But again, you can kind of just scroll along here, just hitting over, and you can see it's going in that 1 foot increment. And say I wanted to check a little further up, and you can even go to a specific station. Say I want to go to 631 plus 40. Just type that in here. Don't even need to put the plus sign in there. Jump you right to that station, and all right, let's check to see what that clearance is between that bottom flange and say this right here. 46, plenty of room. Again, this is a flyover, so we knew we were going to have the clearance here. But yeah, this is a quick way to do it. I kind of like doing this sometimes versus that clash detection report, because then you don't have to worry about trimming your survey file to just the roadway surface, and you don't have to do any of that stuff. You can just kind of come in here and measure quickly, and then check long points here. And then later on, you can go back and do that clash detection for your vertical clearance to get the exact amount and dial it in. And then you can always cross-check it with this cross-section view here too. So now that we've gone over that vertical clearance check, the last thing I want to show you today is the preliminary reports that we have available to us. So under that OpenBridge Modeler workflow, analysis and reporting, we have a couple things here that can be useful in the preliminary design. The first one's going to be input echo report. This is just going to be a report you can run and basically check all the inputs. So a lot of times people ask the question, well, how do we QC a 3D model? Well, here's the best way right here, just by printing this input echo report, and it basically gives you all the inputs for this entire model. Everything from what alignment you used. You can print off the alignment and the chain of profile report to get QC that. The support lines, decks, everything that goes into this model can be printed from this input report here. And it's pretty exhaustive and pretty easy to just check whatever it is you want to check. So let's just go ahead and look at the deck one real quick. Hit submit, and then you can check any of these values here that you might need to check. Quantities report. So this is probably, out of all the reports for preliminary design, this is probably going to be the most useful one. Now in the library here under materials, this one's built up pretty well, right? Because this is going to be an FDOT workspace here. So we have all the materials and properties built into here. But along with that, we have unit prices that we can build into materials. So as I was selecting different materials for the different objects that I was modeling, it associates a cost per cubic foot or whatever your unit of measure is for that material, whatever it is you're modeling there. So with that, you can actually generate a quick preliminary cost estimate if you wanted to. So I'm going to go ahead and select all for all my units in this bridge, hit submit, and take a look to see what this looks like here. And it's pretty nice. It breaks it down by superstructure, substructure, and miscellaneous quantities. And so even here within the superstructure section here, you can see it breaks it out into cubic yards of deck concrete, even the haunch concrete, the beam lengths for the different types of beams we have here, in the lineal foot. Again, using that unit price that's defined in that utility area in the library for the materials, and just go ahead and generating a quick cost estimate for you. So you know how much your superstructure is going to cost here, and even each line item within that superstructure. Going down into the substructure, you can see it breaks it out into different substructure components. So the end vents, and within the end vents, the caps, the cheek walls, the piles, even the beam seats, and then the miscellaneous quantities. We have the bearing pads. If we scroll down into this next section here, we can see it breaks it down into like a little pie chart here to see how much, what percentage of each component makes up the total cost of the bridge. You can get a total cost per square foot of the bridge. In this case here, it's something's messed up with it, so it's not reporting square footage, but when it does, then it'll show that, and then it'll give you a cost per square foot of your bridge, which you can use to kind of use as a sanity check against some of your normal baselines. Scrolling down to the unit 2, which is that steel span, we can see it breaking out the steel into pounds of steel based on the flanges and the webs here, so you can know what your total poundage is here. Again, getting that quick rough cost estimate here, which is pretty nice here when you're doing that preliminary design. Now, one other report that might be useful here in the preliminary design, maybe is the beam report. This one will be set to whatever active unit you have here. So let's go over to, say, like the concrete girder unit here on span 1, set that active, and check that beam report out there. So this is going to give you, beam lengths, true length, and the actual horizontal length, which is what we're used to seeing on like framing plans, bearing to bearing lengths, your beam grades. Sometimes there's rules, DOTs have rules based on your beam grades and whether you have to have slope beam seats or bevel plates, things like that. So you can look at your beam grades to see if you're going to need those. You get beam seat elevations or beam elevations, top and bottom beam elevations. You get haunch thicknesses. You can use these to dial in your haunch loads on your girder design if you really wanted to, and haunch elevations. And that's all I have for you today.